So it doesn't work. So what do we do in the meantime? Well, with all of these other ones, we work with what I call a cognitive web model of cognitions, to sort of think of them more as nodes on a web. And when you pull on one, you will pull on other cognitions as well. When you ask a student to say justify, it's possible that they will have to evaluate and hypothesize and many other things. Now, this diagram is simply the type of diagram I mean. I don't want you to take anything away from this particular diagram, because I think the way that the cognitions might be connected in any particular task could be quite unique. But this is just a kind of diagram that might represent how they could be connected in one particular context. Because when we ask students to do these things, they rarely just do the one thing. They have to pull in lots of other cognitions as they work. Now, one of the advantages of Bloom's was that it gave us just a few to focus on, the so-called higher order ones. But what do we do now? Do we have to talk about all of them? Well, to an extent, because we do all of them a lot of the time. And a lot of our work is involved in what we call doing cognitive audits, is making the cognitive aspects of tasks really clear. So you can see what's happening here. What you're asking them here, they're going to have to do these kinds of cognitive activities. But we have found that 4 cognitions, if used time after time, if focused on for a long time, do tend to pull in just about every other one. And they are, unsurprisingly, from what I said before, in no particular order: evaluate, analyze, justify, and explain. Analyze because it's such a ubiquitous skill, and it's a precursor to so much of what we have to do: analyze in order to interpret, in order to identify. And it is in all learning objectives, or should be. Evaluate and justify because they are the core of argumentation, as it says in the support material for the Australian curriculum. At the core of critical thinking is the ability to identify, analyze, evaluate, and construct arguments. And I know it says that because I wrote it. And I wrote it so I can sit here today and say it's in the curriculum, because I always wanted to say that. So now I've said it. So those 4 we find, not every time, but over time, if you focus on those 4 and say, how am I working this into my learning experiences? How am I working this into my assessment? You get students thinking far more broadly. And really importantly, these are incredibly powerful collaborative skills, because we explain to someone. The thing that we analyze and justify is often the thinking of our peers, or analyze and evaluate, I should say, is often the thinking of our peers. We justify to people. So it's a very important idea. Just to get a little bit memey there, we go, the engine of cognition of the classroom, these 4 skills constantly in play. And there's lots of ways to understand the connections for the extent of understanding and the quality of explanation is a function of the depth and breadth of analysis. The strength of a justification is often a function of the quality of analysis. So if we want to justify why we would do something here, it's because we've analysed something over here. Persuasiveness of justifications is a function of explanation very often. And the criteria that we use for evaluation, what we value that allows us to construct those criteria, are used to justify and explain decisions, and themselves require justification. So there's a lot of interaction between these 4. They're very powerful tetrad of skills. And also just to show you, just to sort of bracket this out if you like, but it's a concept you might find interesting that's come out of our work in problem-based learning. We often see axes in problems from simple to complex. And familiar or unfamiliar is also common, but it's nice to talk about about problems being structured, well-structured or ill-structured. Not ill in a derogatory sense, but in what I would say, there's in the very well-structured problems, there's very few degrees of freedom for inquiry. Like, it's done one way. Okay, you learn the one way. So if you learn to y equals mx plus c in mathematics, okay, here's the equation, here's the variables, there's one way to stick them in and get the answers. No degrees of freedom in your inquiry. You just learn that way. It's very well structured, very simple. As a physics teacher over time, I remember going up the left-hand side of that diagram from simple to complex, but still well structured, still very chunky in the way that it was worked, very clunky and very directed. But what we find is you move towards the ill-structured questions, where students themselves have to come together and understand the ways in which they could move forward and to discuss and justify potential paths of actions, and potential information that they are seeking can be can just open up to an enormous amount of cognitive activity. And so with these increasing degrees of freedom of inquiry, you get much more scope for thinking. So pulling away some of that structure is very useful. That's a different thing to scaffolding, but that's another conversation we could have later. But just again, to show you some of the areas in which we work.